Hi, this is Scott Forbes. Welcome back to Pacifica Science. And if you check out the date behind me, it's a Wednesday. No notes required today, but I do want to go over some of the questions that we had in terms of how to do the math. Now, the actual answers to the questions that were assigned from our textbook, page 10, there's 2 questions on the left and a couple metric conversions. Those are posted on the notes, which is linked down below, pacificascience.org. But let's jump right in. You might remember on the Get to Know Ya, when I was talking a little bit about math, and I mentioned my own high school, Cappuccino High School, which was an awesome high school, and I couldn't wait to take the physics and chem, and I share those personal stories because one of the most important things that we do here is get you ready for high school. We get you ready for 8th grade and high school and beyond. Couldn't wait to take the science, as I had said, but I was thrown into some science before I actually had the math background to be really able to succeed in the class. I want to share with you some of the techniques that I was lucky enough to have the time to go back and learn and then jump back into the science classes. A good friend of mine, Judy Gulch, she went to Cappuccino High School. She is now a PhD researcher. She went forward with the chemistry classes. She's a doctorate in chemistry and biochemistry. And I mention that because if you've got the math background and you stick to it, you can go anywhere. So let's check this out real quick. One of the things that we mentioned was using conversion factors. It's just in our CPM math books that we use here at this school, they show them with a big 1 over them, showing that they're really the same thing on top as on bottom of the fraction. They just might look a little different. For example, 2.54 centimeters is 1 inch. They're the same thing, so that really means 1. It's a conversion factor. When you're doing the math in this class or any class, from here on into the future, you always want to show your units. It's exceptionally important to show your units. Quick story I wrote on the board here to remind myself, the Mars Climate Explorer. When I was first a teacher back in 1999, we were anxiously waiting to see what would happen with this Climate Explorer that was launched. It was meant to go to Mars. I believe it was meant to land on the south pole of Mars, but I got to double check that. But what did happen, when it went into radio blackout for a while, they were waiting to hear from it again, never heard from it again. Turns out they saw pieces of it scattered all over the south pole of Mars. And when they went back to analyze what went wrong, part of the team that worked on the program for the Mars Climate Explorer used inches, feet, miles. The other part of the team used meters. They used a metric system, these meters, kilometers. And when they put the computer program together, it essentially didn't talk to itself correctly, and tens of millions of dollars worth of Climate Explorer ended up in ruins on the Martian surface. That's what happens when you don't pay attention to your units. So make sure you're using the proper units, paying attention to your units, and you do always have to write them. cm for centimeters, in for inches, whatever you're using as your abbreviation. There's some standard abbreviations in the book. Won't go through those now, but make sure you put in the units. If you just give an answer in math class, if there's a quantity of something, perhaps you're talking about the number of items in a bag, and you just say, well, 12. Your teachers will try and get you into the habit of saying 12 what? For example, if you're talking about, in one of our questions we had, how many, I believe it was square feet was the yard that you were asked to measure. If you don't give your answer in square feet, if you just say, well, it was 4,000. 4,000 what? Am I 4,000 square feet? 4,000 square meters? Makes a big difference. So you've got to make sure that you're using the proper units. The other thing that will help you out all throughout your math and science careers are beginning with the formula. There's just a couple of formulas, just a handful, that you're asked to remember. You're asked to commit to memory here in middle school. One of them, for example, speed equals distance over time. Or rate is distance over time. Density is mass over volume. Here's a famous one, E equals mc squared. The thing about these formulas, what you'll be doing in the algebra classes right across the hall here, is just be flipping them around sometimes. Remember, if you know 2, ... right? If you know 2, you can always get the third one. Speed equals distance over time. Well, let's say I didn't want distance over time. Let's say I wanted distance, not speed. Hey, I can manipulate this with just a little bit of algebra. It turns out speed multiplied by time equals distance. And we'll go ahead and challenge yourself to do these other 2 that are up here. If you want a different, say you want volume here, or say you want mass here, how can you change these around? This one's a little bit more advanced. We talk about that a little later when we get to physics. C, by the way, here stands for the speed of light. It's a cool one that we talk about later on. But the point is, if you know any two quantities in these formula, you can always get the last one. That's what we're after here in 7th grade, 8th grade, and beyond into high school. And if you look, when you start with a formula is like your map. If you're going to go somewhere, I used to use a good old paper map, and I use Google Maps probably, but a map shows you where you're going, shows you where you're at. It's a fantastic way to begin. Always start at the top of your paper. If there is a formula to use, write that down first. That's the way to go. Here's a really good example, and a map example too. Let me grab my globe here and I'll show you. One of the things that we study, because we talk about natural selection and evolution, we talk about the way the plates move around the planet. And the famous example, of course, being Alfred Wegener, noticing, of course, that South America, Africa look like they fit together. We now know, of course, that they were once joined. To prove his theory, he had to figure out how these plates move. We now know that they are moving basically at the speed that your fingernails grow. Some move a little faster, some move a little slower. And if you're looking at the average speed that a continental plate is moving along our planet, it's about 2 inches per year. I'm going to give an example of a question that you might see in the science classes here. If plates are moving about 2 inches per year, how long will it take LA and San Francisco to be right next to each other? So you may or may not know, I've already shown the outside of this classroom before. We're on the Pacific plate here, we're moving north. The other side of the plate, the North American plate, just on the other side of Sharp Park Road here, is the North American plate is moving relative to us the other direction, is kind of moving south compared to us, moving north on the Pacific plate. If it's moving at 2 inches per year, how long will it take for San Francisco, I don't have an LA hat handy, to be right next to LA? I'm not sure what I would do with my baseball fandom at that time. I don't know if they'd combine the baseball teams, I don't know. But if you check out San Francisco and LA, well, it's actually a pretty easy problem if you set it up correctly. Let's go look at how we set up and let's pay attention to our rules right here. I'm going to switch out the boards for just a second. And we're going to look at our formula. We want to start with our formula. The formula we want is speed is distance over time. Do we want that form of the formula? No. We want to use this form. We're not interested in speed. They're giving us the speed in the problem, in the question. We want the form. It's the same formula, it's just switched around. We want the form of the formula that's looking for time, because that was the question. How long will it take? Well, we want time is distance divided by speed. Well, if time is distance divided by speed, as long as I have two of those quantities, in this case, distance and speed, I can get this. I can get this. I know the rate, the speed. Well, let's check this out. I've already done on the whiteboard here, time is distance. They gave us the distance in the question over the rate, the speed, 2 inches per year. That's how you read a fraction like that, 2 inches per year. If you look at this right here, I would like you to write it down in this form. Why? We'll see in just a second. It gets really easy to cross-cancel things out. But check this out. We have everything we need right here. We just might not realize it. If I were to multiply this out, I'd end up with 350 mile years over 2 inches. That doesn't make much sense. Mile years, what does that mean? We need a couple of those good old conversion factors. Remember, a conversion factor is just a 1. It doesn't change the value of what we have. We want to get rid of miles. Conversion factor, well, 1 mile is 5,280 feet. When I do a little cross-canceling here, I'll be able to get rid of my miles here. Wait a second, I want to get rid of feet. Feet doesn't help me out because my answer is going to be in year feet over inches. That doesn't make sense. Well, let's think of a conversion factor that will help us out here. Oh, wait a second, 12 inches is 1 foot. When I do a little cross-canceling, the inches drop out. the feet drop out. Look what I'm left with here. 350 times 1 year times 5,280 times 12. All the units have dropped out except for years. Before I even break out the calculator and punch this in, I know that I'm probably correct. So let's do it right now, very, very quickly. I'm a little bit over my 10-minute limit. So let me see if we can punch it on in here. I've got my trusty calculator ready to go. 350 multiplied by 5,280 multiplied by 12 divided by 2. Turns out LA and San Francisco are going to be right next to each other in just about 11 million years and change. If you look at everything that was put in here, the important thing to remember, and if that seemed complicated, the only important thing to remember is before I punched in anything on a calculator, I knew that probably my answer was correct because I was able to cancel out units and get to the unit that I wanted. We'll pick this up next time. Remember, you didn't have to take units on, or you didn't have to take notes on this one. I just wanted you to kind of follow along and see how we'll be setting things up in math class, in science class. Take care. Have a great day, everybody. Bye-bye.